Hey Free Calc, Mrs. Mac here again. I think I finally figured out how to do a landscape video, but we'll find out at the end, won't we? All right, if you grab your second set of notes on arithmetic sequences, I decided last video got a little long, and so I'm just going to do some highlighted examples through these. You'll find a blank set of notes on Classroom, but you'll also find a fully complete set of notes. So it's really up to you if it helps you to write things out, if you want to follow through the examples, but I'm going to highlight a few things through here, sort of shorten up the videos, but still provide you with lots of resources. So if you have any lasting questions, certainly email those, get a hold of me, we'll work through those. So we're going to talk about specifically arithmetic sequences today. I like these because it means that as you move from one term to another, you are adding or subtracting the same thing. An arithmetic sequence is a sequence in which the difference between any two consecutive terms is constant. That means if we thought about those terms as range elements in a function, we would have a linear function. You're adding 5 each time. You're subtracting 2 each time. It is always going up or down by a constant amount. So the common difference is what we call the numerical difference between any two consecutive terms. Now you want to make sure that those are actually consecutive terms to find that common difference. So we refer to that value as D. Isn't that nice? D for difference. So that's how we'll refer to it. So let's look at example 1 here. We're going to look at example 1. This is an arithmetic sequence. You can see that I am adding 8 each time. So my D value would be 8. And then if I want to find the next 4 terms, well, I can think of that recursively. I just keep that going. 61 plus 8 is 69, plus 8 is 77, plus 8 is 85, and plus 8 is 93. There we go. Feels like what we did before. Look at example 2. Are we adding or subtracting a constant amount? We certainly are. We're subtracting 3. So that D value will be -3, and I can look for the next 4 terms by adding -3 or subtracting 3, and we'll get -22, subtract 3, -25, -28, -31. So that's how we would extend arithmetic sequences. Now, we can find the nth term of any arithmetic sequence. Remember, this would be an explicit formula. We have a formula for that. A sub n is going to equal that common difference D times n minus 1 plus the first term. And this is where A sub 1 is, in fact, the first term, and D is the common difference. If we know the common difference in the first term, you can write, sorry, that's hard to read when I don't put it up there. You can write any formula for any arithmetic sequence. Okay, so A sub n equals, now that you can see it, D times n minus 1 plus A sub 1. So let's see if we can put that to work in this example 5. You can see we have an arithmetic sequence. What are we doing each time? We are adding 6. So D would be 6. Do we know the first term? Yes, we do. 7 is the first term. So I'm just going to use my formula. A sub n is equal to that common difference 6 times n minus 1 plus 7. Now that's not in a very user-friendly form. It's not terrible, but we can do some distributing and combining like terms. And we find out that a sub n is equal to 6n plus 1. That's a little bit more user-friendly. And notice it's in that nice linear form, y equals mx plus b, that slope-intercept form. 6 is the slope, but 1, remember 1 would be that y-intercept, that 0th term right behind it. So you can use this formula, always works, or you can think like we talked about yesterday, what would be that 0th term right before that? I could subtract 6 and I would see that would be 1. I'm fine with you using either way. And now let's see if we can find a sub 32, the 32nd term. Just plug it into that formula. 6 times 32 is 192 plus 1 would be 193. Okay. Take a look at number 6, same thing. Find the common difference. Sometimes it's not the easiest to see in the first one. You might find it's easier to see in consecutive terms. We are in fact subtracting 11, so our common difference is negative 11. I think I'm going to use that idea of that 0th term here because I like that. A sub n is negative 11 times the term number. And then what would be right before that 4? Well, it would be like adding 11. So that would be 15. So you can write the formula like that, or you can write it out in this way with the more formal formula. And then we can find a sub 24, plug in 24. Negative 11 times 24, remember you can split 2 and 4 when you're multiplying by 11. Split those terms, add them together. And so that's the multiplying trick for 11. Negative 264 plus 15, that becomes negative 249 is our 24th term. All right, 7 and 8 are much like that, so you can take a look at those on your own time. All right, let's look here and see if we can use what we know about arithmetic sequences to find, in this case, the 36th term. We know the first term's 29 and the difference is 7. I'm just going to write that more formal formula right here. So I have it on this page that we can refer to. Well, if I'm looking for the 36th term, that means n would be 36. Maybe a sub 36 would be my common difference, which is 7 times n is 36. And then I would add that first term, and I know the first term's 29. That's really nice. I can just throw all that in my calculator. That's really 7 times 35. You could walk it out like this, or you might just want to throw it all in your calculator, and you would find that that 36th term is 274. So that formula comes in handy. All right, let's look at 11. We know the first term, and we know the 25th term, and we're trying to find that common difference. I'll go back to that formula again. A sub 25, so I'm really looking for when n is 25 in this case. So 107 equals my common difference times my n value minus 1 plus the first term of 11. And now we have a nice linear equation to solve. Subtract 11, and 25 minus 1 is 24. Divide by 24, and that common difference is 4. Now, some of you are probably thinking, well, I could just like look at the difference between those two, subtract them, and those are 24 apart. Yes, there are ways that you can finagle that in your head. If you have to justify your work, you're going to want to do it with the formula there. All right, let's look at 13. We know a sub n is equal to negative 76, and our first term is negative 21, and the difference is negative 5. We're trying to figure out what term number actually is 76, or negative 76, pardon me. So we're really looking to solve for n, so common difference of negative 5. Again, we're just going to use this formula and plug in what we know. Add 21. I like to add 21 to both sides there, negative 55. You could distribute that negative 5, combine some like terms. We don't have to be solving it in the same way. I keep forgetting to move that paper up. Sorry, guys. Then I'm going to divide by negative 5. So n is 12. All right. Hopefully that's feeling pretty good. A nice formula put to use. Don't forget you can describe sequences and arithmetic sequences in particular with an explicit or a recursive formula. So if I'm looking for that common difference here, is it arithmetic? It certainly is. I'm adding 2 each time. So I could write my recursive formula. The first term is negative 19. And then the nth term, remember, take the previous term and add 2. That right there is your common difference. What are you adding or subtracting each time? And that's the d value we will use in the explicit formula. Explicit formula is an equation in terms of that term number. So my difference is 2. I can use that formula up here that I used with the n minus 1, or I can think, what is the 0th term? What would be right before negative 19? That would be negative 21. And we've got an explicit and a recursive formula for that sequence. All right, just a couple more. We have what we call arithmetic means. We're used to the mean. It's the average, and generally we only thought it was the average between 2 numbers, was halfway in between. But if you have 2 numbers of an arithmetic sequence, there can be more than one mean. The arithmetic means are the terms between any 2 non-consecutive terms in an arithmetic sequence. So they have to be non-consecutive, and it has to be in an arithmetic sequence, hence arithmetic mean. For example, here we've got a sequence 2, 8, 14, 20, 26, 32. We are adding 6 each time. That would be that common difference. The arithmetic means between the number 8 and 32, those are non-consecutive terms. How many terms are in between them? 3. There are 3 arithmetic means. They are 14, 20, and 26. All right, so a couple examples with arithmetic means. We are trying to find the indicated arithmetic means for each set of non-consecutive terms. So here we have a term value of 50 and 118, and there are 3 means, meaning there are 3 terms in between $50 and 118. And there are lots of ways you can use some just good logic to figure this out. But we can set this, if we want to do it in a more structured way, we can set this as the first term. Here would be the second, the third, the fourth, and the 5th term. Now I can use that nifty formula for arithmetic sequences. And we could say that the fifth term is equal to that common difference. And n would be 5 because it was the fifth term, plus the first term of 50. So I'm using that formula again. And n, actually, I know n. n is 5. So now I can solve for that common difference. Subtract 50. 68 is equal to 4d. Divide by 4. And d is 17. So now I know that the common difference is 17. Now I can go ahead and add 17 each time. And let me show you something on your calculator. I like arithmetic sequences because I can put in 50 and hit enter. And then I can add 17 and I let the calculator do the answer. And the first one will be 67. The second one, just hit enter again, will be 84. The third one will be 101. And if I did this correctly, I should be at 118, and I am. So I didn't have to do too much extra in there. I like using that calculator. So those arithmetic means are 67, 84, and 101. Now we can do it with some bigger numbers as well. There are 4 means in between these two numbers. So if I set that one as the first term, then there are 4. So 1, 2, 3, 4, 5. This would be the sixth term, since there are 4 in between. So use my formula again. N is 6. And that first term is 2265. Now you can see what's happening here. We're really just taking the difference of those two, 3570, subtract 2265. I get 1305. And there were 5 steps, 5 times to add between the first and the sixth term. So that difference, I'm just going to divide by 5. And I find that that difference is 261. Now I'm going to find those 4 in between. I'll start with 2265, hit enter. And I'm going to add 261. So the second term, or the first mean, is 2526. The second one is 2787. The third is 3048. And the fourth is 3309. And I'm going to hit once more and hope. Yep, there we go. 3570. It's a nice check for that. All right. One application. Last problem down here, number 23. We'll see if we can put these arithmetic means and formulas in context. On Anna's first birthday, her grandma gave her a check to open a college savings account. Her grandma continued to send checks on her birthday, each at the same amount. At 7 years old, Anna's grandma had given her a total of $610. I'm just going to write that down. And at 18 years old, Grandma had given her a total of $1,270. How much money did Anna's grandma give her on her first birthday? So we're looking to go backwards, but here we have 2 little snapshots in time. So even though this is a sub 7 in our sequence, because that's 7 years old, I'm really going to think of it as a sub 1. And this is a sub 18th on her 18th birthday, her total. But that is really a sub 12 if I'm thinking of this as the first term and this is the 12th term, so that I can find that common difference. So if I think of 1270 as the 12th term, this would be 12 minus 1 plus that first term of 610. Get my calculator over here. So I'm going to take 1270 minus 610. That becomes 660 is equal to 11D. Well, that's divide by 11. I can see that the difference is 60. So now I know the common difference is 60. Now I want to think about this as a sub 7. And now I really am looking for what is a sub 1, what was given to her on her first birthday. So if I know a sub 7 is 610, my common difference of 60, 7 minus 1, plus that first term, a sub 1. Now I can, that's 60 times 6. And subtract 360 from 610. And so Grandma gave Anna $250 on her first birthday. Now, there are some different ways to go about that. This is a more formal way. I'm sure that some of you will just punch away on your calculator, and that's okay too. So that should give you an idea and equip you to work on that first homework assignment. Hope it goes well. Email me any questions.